Thank you all for coming to today's Tech Talk. I'm really happy to introduce our speaker today, Michael Coates. Michael is the Director of Product Security at Shape Security, and he is also the Chairman of OWASP, and he's going to give us a talk today on security. So let's give a warm welcome to Michael.
Great, thanks so much. I'm really excited to be here. I love going out and talking about security. Today we're going to talk about an area that's pretty close to my heart, creating self-defending applications with the goal of repelling attackers. And this is an area that I've done a lot of research in. There's several companies out there that are using these techniques. And I think as we get through the material, you'll start to wonder why we aren't doing more of this. Before I jump into it, a little bit more about myself. I've been in security for the past 12 years. That's what I've done. I've attacked government systems, enterprise, voting machines, cellular networks. Those attacks have all been hired and white hat, so to speak, so nothing too questionable. But in that time, I've seen a lot of really interesting things. For example, I was in 2007, I was in an environment where sitting in my office in Chicago, I was able to, if I wanted to, turn off data connections to all cellular subscribers in Southeast Asia, all from vulnerabilities that we found. Or when testing a bank on the northeast part of the US from my house, the ability to cycle through all the mortgage applications submitted by everyone every single day. And if you're interested in that situation, I guess a developer thought that after you submitted a mortgage application, you may want to submit another one. Now, I'm not actually sure how many times you submit multiple mortgage applications to a bank in a row, but they added a hidden field that would say, continue back, and it passed through an identifier, so you could continue doing your mortgage application. You just change a hidden field, the identifier, step back one number, and lo and behold, you're the previous user, and you can view their mortgage application or the one before. I was shocked. I'm like, wow, everyone, this is my first week on the job. Look what I found. This is amazing. Like, yeah, that's pretty good, and I couldn't believe why they weren't more excited, because those types of issues we found every single week, and that was quite shocking. So let's see here. So I'm at Shape Security. I just joined there recently, about 6 months ago. We're doing amazing things in protecting applications from automated attackers. Some really exciting work that we're doing there. Before that, I was at Mozilla. I built a security program to protect Firefox, web applications, services, infrastructure, led an amazing team. I was talking earlier, that team was across 6 countries. We really explored that remote working setup. And when I'm not working during the day, in the evening I'm involved with OWASP. I'm the chairman of the global board. OWASP is in over 100 countries with chapters. We have 150 plus chapters around the world, 30 to 35,000 people that participate in various ways. And I'll reference a lot of OWASP material here. As you see, the entire slide deck is branded with OWASP. So jumping into this, let's think about applications. The web is powered by applications, and applications contain the most critical information and functionality that powers what we do. The web is becoming increasingly part of our everyday lives. It can tell us how to get from point A to point B. It can manipulate all our data, all sorts of amazing things. Now, those applications are powered by custom code, as you all know. When there's a vulnerability, you can't just phone up Microsoft and say, let's apply the patch. That doesn't work. That's the operating system type of thinking where you can apply a patch and move on. When we have flaws in our applications, they require custom solutions. At the same time, just as there is tons of important data in applications, there's an entire underground criminal element that is coming after that information with financial incentives to steal that. They can take the information, they can take the credit cards, they can convert it into money, and it's, again, organized crime behind it. It's not just individuals sitting in their basements, hacking on computers before dinner. Entire groups throughout all parts of the world with financial incentives to compromise our applications. Now, the reason that this slide deck and this research exists is because of that last point. There's not a lot of visibility. Well, there's a bit of visibility into ongoing malicious activity. But moreover, if I was to ask you guys, would you know at this moment if your applications are being attacked? I don't know if you would. And that's not an insult to anyone here. I think that's the state of security, is we have some systems, we have some intrusion systems, we can detect some types of generic attacks. But what about the ones that attack your custom business logic? What if they're trying to get around your access controls? If they're deep in your application with an authenticated user launching attacks, would you see it? And would you only know that you've been compromised when the New York Times writes a story about it 6 months later? And thinking about it, that's probably not the best way to go about things. So attackers are constantly attacking your applications. They really have no reason to stop. It's not like anyone really knocks on their door that often and says, hey, we saw you were doing this, we're going to arrest you. And again, when we are compromised, how do we know? How do we find out? So what we want to talk about here is how do we create an application that can defend itself? And we're going to look at that in two different ways, because security is more than just the lines of code to make it a reality. So we're going to talk about what those lines of code are, but then how do you approach this from an organizational perspective and the life cycle of security and software development to make that a reality. And we're also going to dive into a live implementation that I led when I was at Mozilla, so we can see this in action. So the AppSensor project I started about 5 years ago, I believe, and it started at OWASP, and it was part of the Summer of Code project back then. And the idea was this: when I attacked applications, like that bank example, there are some things I would do that would be custom to the particular application. But in many cases, there's a lot of things I did over and over again. If I saw a number in the URL, I would increment it and decrement it, see what happened. If I saw a hidden field, I'd swap it out. If I saw an input field, I'd put in gibberish to see what would happen. I'd put in SQL injection attempts, cross-site scripting attempts. And eventually it occurred to me as I started building scripts to automate this and do this in just massive amounts against an application. Why is this application letting me pound against it continually and never doing anything? If I was to walk up to you and begin punching you in the face, you would probably do something. But applications don't. They just stand there and saying, yep, here we are. And so this got me thinking of, if there's so many things I do that are repeatable and predictable, why can't we have the application look for those? Now, you may be thinking, well, WAFs do that, web application firewalls. And they kind of do at a very generic level. Like if I submit a very basic SQL injection attempt of or 1 equals 1. Now, mind you, some WAFs will miss if you put or 2 equals 2. So it's not the most advanced system in the world. But what I'm talking about with AppSensor is let's look inside the code, because that's where we really have concerns, deep in the application. And so I set out to build this project. And the project itself, and we'll get into it more, is a catalog and a resource of how would you detect badness? What kind of things would you look for someone that is coming after your application? And then secondarily, what would you do to get rid of that threat? Now, this project has been picked up by a few different organizations. We published an article in the Department of Defense Crosstalk Journal in 2011, and it's been featured at the Department of Homeland Security summits on building resilient software as well. So it's more than just a part-time project. This project's gaining a lot of momentum, and we have a good group of people around the world that have been working on advancing as well. So let's dive into defending applications. So when I come after an application, there's a lot of different things I'm going to attack. And this is a very rudimentary design of an overall application. But for example, I can attack at the request processing and session handling level. Let's see if the application invented their own session handling. You don't see it as much anymore, but you used to see it. And so we could attack the session IDs, the randomness of them. We could brute force them. Request processing. If you haven't heard of HTTP verb tampering, it's kind of an esoteric flaw in the way some Java apps can handle the method from HTTP, and you could actually change the method to something else, get around access controls. Again, an interesting attack. And I'd go after authentication, of course, as well. How do you protect the front door? Can I get in? What happens if I take out the password field and just submit a username? Is your application ready for that? Is that an error scenario that's going to cause problems? What if I try and lock all of your accounts by just submitting a bunch of fake passwords for everybody? I don't care what the actual password is, but if I cause all your accounts to lock at once, that's an attack in and of itself. Similarly, I go after access control. If I can access a function that's called update address, and I see that that's what the information is when it's posted, What happens if I change that to delete address or delete profile? What if I change a number from a 1 to a 2? Input validation. Again, anytime I see any sort of field, I'll start to add different malicious data, SQL injection attempts, cross-site scripting, large amounts of data. If I submit 100 characters to a small field, what would happen, or 1,000 characters? And then even in business logic, and I think this is, a large amount of information is captured in the term business logic. But this is how we step through an application. If there's a multi-step transaction in an application, what if I jump from step 1 to step 3? Did I suddenly skip the part where you charge me? And these kinds of flaws, again, no sort of outside generic system would ever be able to detect that. But inside your application, you know exactly what's going on. And so the point of this is there's a lot of different places in your application that I, as a bad guy, will attack and look for potential flaws. So when we want to think about defending that application, what if we put tripwires or alarms throughout the application in these different spots so we can see when someone is trying some of the activities? Now, the idea with the tripwires, or as I call them in the project, detection points, it's not to enumerate every single possible way someone could do something bad, but it's instead a way of alerting and having an alarm system when someone's trying to do something. So you'll see me putting in a bunch of gibberish data into a field. You don't know exactly what my goal is, but you know that that's bad. Now, one thing that may pop into your head at this point is, well, it could be bad, or it could just be somebody where their cat jumped on the keyboard and hit a bunch of characters. So we need to be careful about these different detection points, kind of put them in two categories, the clearly bad activity and then the, questionably it might be a problem. One that would fall in the clearly bad category is if I was to change a hidden field. There's not really a good example where you can say, yes, my neighbor was on their computer and they accidentally opened up a proxy, intercepted the request, and then changed the hidden field, hit submit. Not something you kind of do by a mistake. Now, on the other side, a single tick in an input field is a great way to check for SQL injection. If it throws an error, you know there's a problem. But you can't say that every time somebody puts a single tick into a field that that's an attack either, because that's fat fingering a password, that's typing a name like O'Malley that actually has it in there. So you have to build out these two different situations. So in the project, what we've done is identified over 50 different attack points that are in the category of definitely bad. This is not something happening by mistake. And we go through and categorize those into different categories like authentication-related, session, access control. And they also fall into two different categories within that of signature or behavioral. And everything we've talked about so far is a signature-based approach to detecting badness. If they do this type of activity, that's most likely bad. The other side is behavioral, and I think this is an even further area of research and advancement. When you use an application, there's a normal way to use it, and then there's ways that are just odd. Like, it might make sense for me to update my address once a year, once every few years. But if you see someone updating their address every day or 100 times an hour, they're not necessarily sending you anything malicious, but they're clearly trying to do something. And we don't necessarily know what it is, but we do know that it's not normal, and we should dig in and watch this user more closely. And another, maybe a better example would be if you have like a status update. Updating your status many times per second, they might be trying something. They might be trying to get some sort of attack in there that will fire, and they're testing it. So there's a whole way of thinking of if someone's doing something bad in the way they use the application, let's try and detect that as well, and then potentially respond. Now, what do you do with all of this different information? You have these different detection points, these different alarm systems, so to speak, and by being inside the application, you can actually report those back to a central user store and log those against a user. So once the user is authenticated, because again, the authenticated portion is the meat of our app, where all the sensitive operations are happening, we can monitor what they're doing, and if they exhibit many different types of malicious activities, we then know this user is up to problems, and that's where we're going to take, as we say, a response action against that user. Now, what you may want to do is just get rid of the user. Why don't we lock them out of the system? Log them out. Maybe their session was hijacked and there's somebody doing these malicious activities on their behalf. So we'll just log them out, make them prove they have their password to log back in. Maybe we want to be more aggressive and lock their account entirely or disable that account. And there's a wide variety of other options like alerting admins, sending specific messages into your risk and fraud systems. At this point, there's a lot of different ideas that you could explore. The reason this works well is if we consider the authenticated portion to be what we really want to protect and double down on for security, by locking them out, you've removed the threat from the equation. They're now at the outside of the perimeter, and as long as you have a strong perimeter for your application, you've removed them from concern. Now, the reason this works is that even if I, as an attacker, find a vulnerability, a flaw, let's say I found a SQL injection flaw in your app. And brief aside, years ago, I was testing a Fortune 100 company, and I found in one of they had hundreds of websites, I found one website that had a small SQL injection vulnerability, but it only displayed a limited amount of information in the error message, maybe like 20 characters. And I wanted to enumerate the information to show the client that, yes, this flaw had these actual impacts. I could get all of your database. And so what I had to do was write very precise messages that enumerated each table character by character in that small amount of output. If first name of first table equals A, then report true. If not, false. And then with the script, step through, and then I was able to map out the entire table and start pulling down records, all in a 20-character error message. So when people talk about detailed error messages, that actually does make a big difference. But back to this. So when doing that, exploiting any sort of vulnerability takes more than just one or two requests. You have to finally craft that exploit so you can either see the cross-site scripting attack, execute, get the SQL injection to run the way you want. And that's only after you've found the vulnerability anyway. So my position with AppSensor is that as an attacker, it could take me, let's say, 8 requests to find a vulnerability and craft an exploit. And I think that's probably very generous. I think it would take more like 20, 30, 50. But if we have this AppSensor type defensive approach, it only takes us 3 or 4 indications of someone being malicious for us to say, yep, this person is definitely a problem. We should get rid of them. And so if we can find them as being bad before they can actually weaponize and exploit a flaw, if they even find one, then we win. We win that equation by kicking them out every single time before they could do anything bad. Now, if your application is set up such that anyone can just go and create another account, they'll just create hundreds of thousands of accounts automatically through automation and keep doing this, and it kind of defeats the purpose overall. So this only works when you have control over your account creation and users are limited into how they create accounts. Now, I mentioned web application firewalls briefly at the beginning, and the reason I think this is a whole different approach is the idea of AppSensor is putting this defensive capability inside your application. Because inside your app, you actually understand custom business logic, you understand access control, you have access to the user object. And other approaches are more generic. A WAF sits outside of your application. It can only detect very generic things where you've built a signature. And then there's this other approach that people say, well, we don't need to do any of this because we have logs. We have detailed logs. And so I'd say, go look at your logs and let me know how many times you were compromised last year. It's not great when you find out after the fact that many months ago, lots of data left, if your logs even happen to be that detailed. Now, how do you take an idea like AppSensor and actually make that a reality in your application? We know that building software is way more complex than just throwing some code up on the screen and saying, make it so. So some of the ways to think about bringing this into your application, first off, start in threat modeling. Think about the critical business functionality. Where are the parts of your application that are the most important to you? If someone was to abuse a particular aspect of your application, what would that be? And what is the worst case scenario that could happen? After you have that, you can say, what kind of detection methods would someone try against this? If there's fields where you're accepting user input, that's a great place to look for malicious types of input that's being sent. If you have a multi-step transaction, people jumping through that transaction out of order. If it's limited to certain users, any sort of access control flaws or violations as someone tries to invoke it that's not supposed to, again, another detection method that you'll want to capture. So an example, let's say we have an update permission functionality in the application. We consider this to be critical because if they get permissions they shouldn't have, all sorts of bad things can happen. That page accepts an integer, which is the target user, and another integer, which is the permission being granted, specified by 1, 2, or 3 for read, write, or delete. And there's also an access control requirement that only a power user can access the page and invoke the functionality. And lastly, that the target user must be a non-admin. So if we had this example and we're working through the threat model to determine detection points, here are some of the things that we might create. If, for example, a non-integer was submitted for the target user, or if there was an invalid number submitted for the permission granted, we said there was 1, 2, or 3 were valid. So if I submitted 0 or 4, that would be an indication somebody's up to no good. Forced browsing to the page from an unauthorized account. So I take a regular user account. I know there's an update permission because I'm guessing. What if I just try and forcibly browse to that page? Another thing that I would do as an attacker is even if I can't view the page, what if I just forcibly submit the post request? Like who knows what the view is? I'll just guess and submit the post and see if that gets through. The target user is an admin or an unexpected rate of use. Again, back to the idea of behavioral analysis. 100 permission changes in 10 seconds would be suspicious. So these are all things that we don't necessarily know what they're trying to do. We don't know if they're trying to find a cross-site scripting flaw or SQL injection or access control. But we know they're doing things that are not supposed to happen. And depending on how our application is created, if it's a drop-down that says 1, 2, or 3, we know if they submitted 0 or 4, they have purposely avoided the application to do that. And we know, again, they're up to no good. So at this point, you want to say, what kind of tolerance do we want to have for these activities? If we see anybody doing something bad, do we want to immediately lock them out, take immediate action on the very first indication? Or do we say that this is so critical and we never want to have a false positive, so let's just alert an admin instead and have them look into it? But the risk analysis for how you react will be different in every case, and getting agreement on how you want to do that is key. And once you have that, you can look at all the different response options. And these are all mapped out in the project as well. Do you want to log some information about this? Alert an administrator, lock out the account. Other ideas, you could send the user off to a honeypot, a copy of your system, let them keep going, let them attack, see what they do. There's a lot of different options. So when this all comes together, you have the two big areas. You have your threat modeling phase, where you're identifying your unique app attack vectors. You'll also have some generic common attack vectors, like generic cross-site scripting attempts. Those all funnel into building these attack detection points we talked about. And you also do the other element of risk analysis with your teams. How aggressive do we want to be on response? What do we want to do? And then this all comes together in design requirements that you can put through your normal software lifecycle. In this process, you'll get a variety of different parts of the organization involved, from architects, developers, business owners, security specialists, and there's different roles that they can each play throughout that process. So I want to talk briefly about a real implementation of these ideas, that it's more than just theoretical. So when I was at Mozilla, we wanted to put these ideas into practice to protect some of our web applications and our web services. And in that situation, we had a back-end SIM of ArcSight. And the way we started doing this is we used something called Common Event Format. And this was an emerging standard on logging, and we were able to create custom log messages in our application that we then funneled to the SIM, and that was the SIM acted as the kind of the brain of the operation, where we could have all of the activities against a user totaled up, and then we could kick off scripts or other actions from that device. And so this was enabling us to do the reporting mechanism of the AppSensor idea. So in this scenario, we used syslog that was already set up and already working between devices, piped that over to the SIM, and it worked really well in the multi-tiered architecture. So what we were able to create from this is a central point that had our application layer attacks, and also the operating system attacks or network attacks, because everything in the SIM could come together in a single place. And this gave us the full knowledge of the entire stack of attacks. And I think this is really interesting because a lot of attacks are more complex than just a single attack at one layer. You know, an attacker may come after the application, but they may also say, well, can I just get in from a telnet connection or a generic FTP type password? So there's a lot of different ways they'll come after the application. Now, once you have the information all in a central store, you can do data analysis, you can do maps, trends, and you can see, for example, how many different IP addresses are generating failed CAPTCHAs on the create user account. And this is interesting because in the normal case, you would expect or you would hope that a CAPTCHA would block an automated activity. But what we're seeing now is the tools to defeat CAPTCHAs are growing. And so the rate of success of CAPTCHAs are continuing to plummet. On top of that, somebody trying these scripts may generate a bunch of failed alerts. So we know at that point, if they're generating lots of failed alerts, that they are trying some sort of new bot out that's not effective. Now, we have to be careful because, as you guys all know, when you see CAPTCHAs, users themselves generate a lot of failed CAPTCHAs. Try as I might, I can never answer one in more than 3 or 4 attempts. So, but when you see hundreds of failed CAPTCHA attempts, you know someone is using automation, using scripts to try and create accounts automatically. User authentication failures. If you've heard of account takeover attacks, there's been a ton of breaches over the last few months. Interestingly enough, when you create a slide and you want to talk about breaches that are of interest, you don't have to look very hard. You just go to Google News and type in security breaches, and it's like whatever happened that week. Kind of a sad state of affairs. But take, for example, a few months ago where a large software manufacturer was breached. There were 50-some million accounts that were put out onto the web. If I was to take those 50 million accounts, use an automatic script, test them all against your login page, how many of those usernames and passwords from that other site would then work on your page? And if I distributed that from a botnet, you'd have a tough time figuring out, is this an attack, is this normal use? Now, one thing you can do is look at your authentication failures, and you'd see a spike in activity. This would let you know an attack is underway, and it would put you in that tricky spot of how do you want to respond to defend that attack? Do you want to lock all of those accounts preemptively to protect the user, which was a little aggressive? Do you want to try and block an IP address and hope that you're hitting not universities and hope they don't have a botnet? If you were to use something like a CAPTCHA, that would be a very blunt force hammer approach that would be pretty intimidating for all of your regular users to see a CAPTCHA on every sort of login page. But nonetheless, having the information of the authentication failures will let you know what's going on, enable you to start thinking about those solutions. The other thing that we were able to do was trend analysis. And this is kind of a fun thing to do across the application because, again, our goal is not to say we know what the attackers are doing, but let's look and see if we can detect badness, if we can detect irregularities, so we can then investigate and say what's going on. So if you take different types of functionalities of the application and you map the normal trends of use, if you see a sudden spike on Mondays, is that because people are coming back from the weekend and using that? And that's fine. Then you build kind of your normal pattern across the days of the week. But what if that Monday suddenly triples, quadruples, 100-factor increase? Now you have to wonder, did we make a news story and everybody's coming to our site? And hooray, that's great. Or is this, again, some sort of attack, something that's being automated that we need to look into? And without the trends, you won't know until you're compromised and you're going back and looking forensically and saying, oh, well, wow, look at this. They use this page 100,000 times, whereas it's normally used 10. I wish we would have saw that ahead of time. So this sort of proactive type approach of looking at trends can definitely help you identify new types of attacks. It's also interesting to look at the top users that are failing authentication within the application. Is it a user that's being targeted for attack? Or is it a user that may have some sort of script that's set up and they change their password and suddenly the script is failing over and over? But again, if you see a particular user, you can go and dive deeper and see what's going on there. And one of the other interesting things we were experimenting with was this visual mapping of the application. And what we were able to do is create this map that showed the operations that were being performed that are represented by squares, the IP address that was doing that, and then also the associated account. And so in and of itself, it's interesting. But as you start to dive into it, you can see, okay, here's an example where we have a change password. We have a few different user accounts doing that, all from different IP addresses. Authentication failed activity. Now, what you can imagine is that this would start to visually show you some things that are interesting. If you see a large number of authentication failures, then followed by a password change, or a successful account, then a password change, that may be something that you see visually that you didn't have any sort of rules or logic set up to catch before. And you say, oh, wait, this could be a brute force attack, followed by a successful login, then followed by changing the password to take full control of the account. So now we want to go back and build some sort of custom detection of this type of flow of activities. So this was just an interesting way of taking that information into a visual view where you may be able to see patterns that you had previously missed. So the idea of bringing application defense and protection into the application, I think it has a strong future. We can detect these malicious patterns. We can see what users are doing before they breach us. And as I've attacked these systems over the years, it's just really been interesting to me how this isn't in place. Because how do we expect to defend an application in reality against all the different attackers that are out there? We build our applications as secure as we can. We apply best practices for security controls. We have network defenses like firewalls, but as you know, like these types of defenses don't do a lot. A firewall is just designed to block out unrelated ports. It lets everything into the application by design. We talked about WAFs that are a very generic signature-based approach. So it always baffled me why we have nothing custom to the application that's really helping defend these applications. By adding an AppSensor idea, we're also able to get something that's very helpful, which is just metrics. Like how often are we being attacked in an application? We can give you data at the network level. We can say there were X number of port scans, X number of attempts to get to port 23. We could show you generic stats, like this generic script went across and tried a SQL injection attempt. But how many people are actually trying to abuse your application logic and the access control systems, for example? And one of the other things that I found even in the Mozilla use of this was that we actually found bugs in the software that we thought might be security issues at first, and as we dove deeper into them, we were able to see that, this is actually a bug in the system. So we were able actually to increase the resiliency of the software overall by providing that information back to the development teams to go ahead and fix those issues. So the big things that I want to take away from this is that if you have a critical application, you need to think about more than just the status quo of security, because the status quo isn't getting us really anywhere. We have tons of applications being breached all the time. And if these applications are what really hold the most critical data, if they have hundreds of thousands of records for users, including financial information, health information, we need to do more than we're doing as an industry to protect these applications. And the way of doing it where we react after the fact, you can look at the big retail breaches. Yeah, they're looking into what happened. It's taking them weeks and months, and they're starting to tell the story of this is how we were breached. I don't think that should be the bar of how we do things. We shouldn't say, please dig in afterwards and tell us how you lost all the data. We should be saying, why do we not have systems that see this happening as it's going and stop it? And so that's what we need, is immediate response. Now, that will bring you to the idea of kicking out attackers, shutting down portions of the application if they're being under attack. And I didn't mention this earlier, but this is kind of like the submarine theory to defense. If you have one particular part of the application that is under attack, say people across the organization or across the application have all suddenly started updating their status at ridiculously high rates, something astronomical. What you could do is just sort of wait around and keep investigating and hope you figure out what's going on. But what could be happening is you could have an application worm that's exploiting something like a cross-site scripting vulnerability and a CSRF issue that's propagating throughout your site, like what happened to MySpace, what was that, 8 years ago? In that situation, the website actually, they brought down the whole website because they couldn't figure out what was going on, and it was running rampant. Now, if you'd use this kind of submarine theory of defense, what if you were to detect that happening in real time and say, you know what we're going to do is we're going to turn off the update status functionality and let the rest of the site stay up. So the users can't update their status, they're frustrated about that, but your site doesn't go down. And so this type of thinking, again, I don't think we have this in many applications, but it's an idea that makes a lot of sense in submarines. You don't want the whole submarine to sink just because you have a hole in one room. You close off that room. But I think we can use those kinds of ideas in applications as well. We see something going wrong in this area, lock it down, we'll figure out what's going on, but let's let the rest of the system survive. And these kinds of ideas all go towards preventing and limiting compromises. Now, if you're going to undertake this idea of AppSensor, it does require more than just one individual adding some code. So bring in your team, bring in your organization. But I think that with the combined efforts of multiple teams, you can add these things fairly simply to your application and get a lot of interesting information and then potentially huge benefits. Now, the AppSensor project itself is online. Everything at OWASP is free. How many people are familiar with OWASP? Sweet. There's a ton of good information there, from cheat sheets to projects to tools to code. So this is one of the many projects. So you can find all the information there. We have a mailing list for questions. And my information is there as well. And then I wanted to save some time to talk about questions on these ideas, things you've experienced, things around security that you might be interested in. Yeah.
I was curious, how exactly does it go about adding vulnerabilities, such as if they're entering or 1=1, for instance? Would that be manually added, or would there possibly be some type of pattern matching system to detect? We should probably add this rule because we see it happening enough, and there's a script released on Metasploit or what have you that happened to exploit this recently.
Yeah, in terms of detecting the malicious input that's searching for a flaw, you could do it as a very rudimentary, just look for literally or 1=1. And you'll find people that just try the most basic attempt. I think a pattern matching approach would make more sense because anyone that's a little bit smarter will just change that. Since they know that many WAFs actually operate that way, they will just by default change it to or 3=3. Or any sort of Boolean logic that comes out true. But again, we're not trying to detect every indication, every possible way of being bad. We're trying to set enough different alarms so that we will catch them tripping up at some point. So they will, no matter what pattern matching you build, there'll be a way for them to get around that one specifically, but you don't think that every single step they'll be able to get around every single way you're looking for them.
On one of your slides, you mentioned SIM and integrating security both at the app layer, the network layer, and the OS layer. Given that in our profession, network engineers and software engineers are different people with different educations and different backgrounds, usually working on different teams, do you have any practical advice for how to, as a software engineer, how do I get better at understanding networks or vice versa, or any advice for how to bridge that gap?
Sure. From the security perspective, most organizations will have a team that will handle the responses, like the information that comes in. So they can work with the software teams, the networking teams, to make sure everything's plugged in. And then that security team can analyze the information, go back to the people that they need to work with. One thing that I found successful in organizations is to do something called like a security champion, security leaders program, where you identify people throughout different teams that have a second hat of security, and you bring them all together across the organization. And they can all share things they're concerned about, areas they may want to dig in further, and also what does security mean in application versus network. And so that then becomes a scalable approach in a larger organization where your core security team that is experts in security, that's what they do all the time, shares their lessons learned with this security champions group, who then go back into their teams and be representatives of security while the security team isn't there. It's like ordering a hot dog, right?
Yeah.
Pass it down the aisle.
So you spoke a lot about intrusion detection. How would you suggest a team or organization goes about more proactive, like pen testing process for their applications they're developing?
So separate from the idea of intrusion detection, you're saying?
Yeah, just so that in addition to intrusion detection, they're looking at, okay, how can we catch this before we get to the point of having there being intrusions?
I see. So looking at security across the lifecycle, I've done actually entire presentations on the different ways to take security into each step of development, because you're right, what we're talking about here is the very last step. After you've built software that is, in your mind, as secure as possible, and after you've had someone else test it, like you're talking about, how do we maintain its security in the wild? So for something like penetration testing, I consider that to be something you'll do at the end when you've done everything you can and you say, all right, let's see if somebody else can happen to find something more. In penetration testing assessments, you could do a black box style where it's blind and the person just comes in off the street, so to speak, and knows nothing about the system and says, what can you find? And then there's the other variation where you say, let's do a white box test where we say, here is our source code. Don't spend time trying to guess about how things work. Here's how it works. Do you see any problems? I think you get the best value from that. The other variation is more of it's a little gimmicky because it just doesn't provide the same value. Like, give them all the information they can. Let's skip all the time-consuming parts of guessing how it works. Is there a flaw here or not? It's good for penetration-type test or third-party validation to have a target in mind. These are the key flows we're most concerned about. We've done our threat modeling. We say, this is the highest risk, so focus on this. It's great if you found a way to change the color of my background. I don't care. Focus on changing people's passwords. So giving them a little bit of guidance is really helpful too. Mm-hmm.
I have a question over here.
Yes.
What's your take on applications that are too overly protective? In other words, like there are some websites that I only log in once a year, and a lot of times I don't remember my password, so I'm forced to, sometimes it locks me out, or I have to call customer service, or I have to wait like X amount of hours before I can log in. Like, what's your take on that?
Yep. Too many times in the security field, we become overzealous about security. And I mentioned at a talk in OWASP, California, to a room of mostly security people, that if we as a group built a car, it wouldn't move. Because we'd be like, well, if it goes too fast, you might crash, so it should go slower. And the windows, we can't have windows, they might break. And the brakes might not always work, so let's just make the wheels not turn. The idea is we need to have appropriate security controls, because a system that is so secure that no one uses it doesn't provide any value, because they'll use a competitor's service that will be less secure because it works. So it is a fine trade-off of what is an acceptable level of business risk. Things happen, things can go wrong. There are fraud levels that are accepted. So if we try and drive fraud to zero, you will drive users to zero too. So I am strongly supportive of never using the most security, because the most security is not always the best. You have to find the right line that is acceptable to users, and we can't just back down because users don't like it. We have to find that right line. But again, over-engineering security is a very bad scenario.
Are there any performance implications of integrating a project like AppSensor into basically your web application on your application server? Like, does it affect like response time?
Yeah, that's a good question, and one that comes up pretty often. The code that you're adding is small. You're like literally 3 to 5 lines for these different detection points of if you get this kind of scenario, then throw this alert, throw this log message. But those also only happen in the error cases. So if you have a detection point around access control violations, the code will only be invoked when someone does something to violate the access control policy. So the normal flow of the application, which you'll see 99% of the time, will never encounter that code at all. And even when it does, the code is so minuscule it shouldn't impact performance at all. The only scenario you'll want to be careful about is if you're doing some sort of analysis on like every request that comes in. If you're saying, did you submit this information, and we need to check every single HTTP request, that could have implications. And it's probably not worth the trade-off in value. But everything else will be super fast.
On one of your slides, you mentioned threat modeling. Do you have any advice for those that are new to threat modeling for what's a practical approach to that? Any tools you'd recommend, or procedures or guidelines?
Yeah, there's a few models out there. There's, let's see, Stride and Dread, I believe, are popular ones. You can stay away. You don't have to be as formal. Like, really get a group of people around a whiteboard. Get somebody that their specialty is security, get some developers, get an architect, and say, what could go wrong? What are we most concerned about? And you build a list of all the scary disaster scenarios, and then you start to think about how likely are these? Because sometimes, and I've seen this rattle happen with teams, they know they should be concerned about security. So like, this could be bad, and we need to fix this. But the likelihood, like the steps that it needs to happen that need to take place for it to happen, are so unlikely that it's not a high consideration. Putting it in different terms, if you need to break into the White House in order to do the next thing, you can probably say, well, we're not so concerned about that. That's not a big risk. But again, yes, Stride and Dread are a couple examples, and then just the whiteboard approach of thinking about what are some abuse cases, what are the bad things that could happen.
So a follow-up on Drew's previous question. How do you deal with the scalability issue of doing threat models on each of your applications? Can you spot trends, or how do you see companies going about doing that?
Yeah, the organizational decisions around security are challenging because of, just like you said, scale. If you have one security team that has to do everything, that only works when your organization is like under 50 people because quickly they're the bottleneck. So the idea of the security champions is to integrate that, is to create that scale. And so then you have, through that program, individuals that are trained in each team. And what you want to do is create for them a threshold of saying, in these scenarios, you'll want to do a threat modeling session. Now, we want to set it up so you feel equipped to do it yourself and you don't have to bring in other parts of the organization. If you get stuck, of course, bring in a security person, but hopefully they're self-sufficient in their team. And then the threshold is important too, because you don't want to threat model everything. It takes a lot of time. So perhaps the threat model is if you're touching this part of the application because this is critical, or if you're dealing with PII or PHI, then you want to do threat modeling. So you kind of have those bars of, in these scenarios, we'll definitely want to threat model.
And one more question, kind of following up on that. How do you incentivize already busy engineers to join a security champions group or some kind of security governance board? How do you go about getting people to actually buy into that without, trying to avoid the security crew?
I've seen that in a large enough, in a large organization, you'll get enough people actually. It seems that it's becoming such a prevalent issue that people do care about it more. But I think the underlying question also there is if you have activities that you need to happen that are outside of the incentive structure, that are not tracked, that are not accounted for in any way, people naturally won't do them. It's just human nature. So building in some sort of incentives, there we go, incentives to that will make a big difference too. Yep. I think we have time for one more question.
You mentioned one of the things you might react to is drop them into a honeypot. And I just wondered, are there tools for building honeypots that maybe could walk your site and then do something other than creating a copy of your own site?
So I looked into honeypots years ago, and I did not know of any of those at the time, but I also haven't kept tabs on it since then. I know there's a couple of projects out there that have been doing a lot of great honeypot stuff. I unfortunately can't point you to anything particular, but I wouldn't be surprised if there is. Yep. Well, everyone, thank you so much. My contact information is up there. I really enjoy the questions. There's lots of different interesting things we all learn from security discussions like this. Hopefully the AppSensor project is interesting. I think the idea of intrusion detection and elimination or repelling attackers inside the app is really the way we have to go, and I hope this information helps take us one step closer. Thank you.